Jai Hind all of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering at Ajay Garg Engineering College. So, today my next important topic that I am going to discuss today is on linked list. Okay, this is one of the important topic in data structure, in subject data structure. So, today we will learn about how we are going to implement a linked list via algorithmically as well as programmatically. As we know that we have to implement the concept using C language. So, today we will learn how to create a linked list, how to insert elements in it, how we are going to travel the elements and how we are going to delete the elements. Okay, the concept I will show you and try to explain with the help of a C example how we are going to create, how we are going to implement linked list in a C language. Okay, so today we will discuss about a brief introduction about linked list, simple linked list, how to create a node, traversing, searching, insertion and deletion. Right, students? So, what is linked list? Firstly, we know that linked list is also called as one-way list. Actually, there is a different types of linked list, that is single linked list, yeah, or we can add single linked list. Okay, circular linked list, this is second type, circular linked list, doubly linked list, okay, circular doubly linked list. Also there is header linked list is also there. Okay, so these are the different types of linked list. Today I will focus on single linked list. Okay, so this how we are going to define a linked list. Linked list is defined as a one-way list. It is a one-way list. Okay, it is a linear data structure. It is a linear data structure. Okay, where the information is kept in a node. Okay, the information is kept in a node and a node is divided into two parts. Information is kept in a node and the node is divided into two parts. First part is called as information part and the second part is called as link part, or we can it address part. Okay, students. So, simply it is a one-way list, right? So, we can show you a linked list with the help of some nodes. So, this is an example of a linked list having 4 nodes, right? So, there is some address. We will call a starting address. This start will keep the address of a starting node and the address part of last node will contain the null, which will represent key we reached at the end. Okay, students. So, this is a linked list, right? So, it is a linear collection of a linked list. I have taken this PPT from, downloaded it from Oxford University Press because we are following a book, Shroom series. Samuel Lipschutz is a standard book which we follow. The algorithms of which books are followed. Okay, when we used to study, we follow that book, and nowadays also we will follow the same book. Okay, so the PPT I have downloaded from website by googling. Oxford University Press PPTs are there. Okay, so the linked list is a linear collection of data elements called nodes, as I have already discussed, in which linear representation is given by links from one node to next node, like this. Okay, this is my first node, second node, and so on. Okay, similarly to array, it is a linear collection of data and the elements of same type. If we want to keep the integer type of elements, then we will keep it. If we want to keep character types of elements, then we will keep characters in the information part and so on, like this. Okay, na? The difference is that in array the elements are stored in contiguous memory allocation. The element is stored in contiguous memory allocation in case of array. Contiguous memory allocation, 1 by 1, 2, 3, 4, like this. And we know that array is accessed with the help of a index position. Okay, right? But in case of linked list, for example, we have a large pool of memory and the memory is divided into track and sector. The information of a node can be kept anywhere. A, B, C, D, E, F, right? And they are linked with a link. link anywhere, randomly in anywhere in a memory. That is not lined in consecutive memory, but in array it is in consecutive, consecutive or contiguous memory allocation. Okay. So the elements in a linked list are dispersed in various location. Okay, students. So this is the concept of linked list. So linked list is a data structure which in turn can be used to implement other data structure. That we know we can implement stack, we can implement queue using linked list. Okay. For static implementation we will use array, and for dynamic implementation we will use linked list. Think like this. Okay. So the elements of linked list. So as I have told that the node is divided into two parts, data part, or we can say information part, and the next is pointer part. Okay, link part. So in a C, how the node is represented? The node is represented using a the node is represented using a structure. Okay. So what is structure? We have already studied. Structure is a data type. If we have different types of data members existing, for example, first data item is data, second is a pointer, right? So for that I have to declare a structure. Okay. So by using this struct keyword, and the name of my structure is node, and I know that the node is divided into two parts, information part and link part. So this is my information part, int data, and this is my link part. Why I have initialized this? This is called self-referential pointer. This is called self-referential pointer because this pointer is used to point to next node. So star next is of struct node, self-referential pointer. Okay, students. So this is simply linked list. We can show diagrammatically like this. Okay. The last node will contain the null. This is null, which will represent कि now we reached to the end of a linked list. Okay. And the starting address will keep in the start. Okay. So these are different operations that we are going to perform. We are going to create a node in a linked list, travel, search a node, insert a node, where we are going to insert at beginning, at end, after, before. Similarly, we can delete the element at end, before, and at last, short. Okay. So how we are going to create a node? As I have told you, the static implementation is done using array. Okay. And the dynamic method is like this. We are going to use this statement for creating a memory dynamically for a linked list. Okay. Malloc size of struct node. I'm just wait a minute. I will just explain you within a 2-3 minutes how we are going to create a linked list. This method is dynamic because we know that we are using a malloc. Malloc is a dynamic function. Okay. So how we are going to create a node? I've just explained you. Okay. After doing this traversing and inserting algorithm, I am explaining you. Okay. So what is traversing? Traversing means we are going to visit each element in a linked list. Okay. So while traversing, what is my aim? While traversing, for example, this is a linked list. Okay. This is a linked list, and this variable start is pointed to the starting location. Then how I am going to start? So first of all, we have to keep in mind how this linked list is maintained. Okay, in memory. So we have assumed that there exists a list. What is list? Let list be a linked list. Okay, and this linked list is maintained in computer memory using two linear arrays. First linear array is called as information linear array. Okay, and the second linear array is link like this. Okay. So if I show you the illustration, memory representation, so it will be like this. For example, this is my one linear array. Okay. The name of this linear array is info. Second, this is my second linear array. What is its name? Its name is link, है ना? So we have some index position. For example, any position 100, 101, 102, 103, 104, 105. These are the addresses, right? Now I have to store some elements A, B, C like this. ठीक है? So for example, A is here, B is here, C is here. So A 104, B 105. Now I think you can understand the start will point to this reference 101. In its link part, it is appended to 104, B 105. It is pointed to 105 and there is a null in C like this. So this is the memory representation how we maintain a linked list in a memory. So in a memory, we will represent it using a two linear array info and link. Okay, like this. So if I have this condition start is equal to null, what does this mean? This means that my original linked list is empty. There is no element exist. So if start is equal to null, then there is no mean of searching the element. There is no mean of deleting the element. If start is equal to null, right? If start is equal to null, now we have to insert the element one by one in a linked list. Okay. Now this is the single linked list. This is the structure of my node. Okay. This is the algorithm. So initially what we will do? We will initialize the variable. So there is one pointer variable ptr. So while writing the algorithm of a linked list, any algorithm, every variable has assigned its own work. You have to keep in mind. This is very important. Okay. So this ptr, what does this ptr variable will do? It will point to the current location where we are in a linked list. Okay. So what we have done initially, we have initialized this pointer variable. We have put the value of start to ptr. Okay. Now what this start will do? For example, this is my linked list. This is my linked list, and start is pointed to my first node. This is my linked list, and so on. Okay. What I have done, I have initialized the value of ptr. Okay. So I will check is null is there in the information part. If null is not there, then this pointer will increment by 1. Right? Now I will again check. Is there is null in this address part? No, then again I will increment the ptr plus 1. Okay? Now I will check is there is null part. If there is null part, then the loop will terminate. Okay. And now after traversing, if we want to print the values of these information, this data, I can print. If I print the values of how many nodes are there, then I can also print it while traversing. Okay. So this is the simple algorithm, initializing ptr, putting the start value to ptr. Repeat step 3 and 4 while we will check whether there is ptr is equal to null or not. If the ptr is not null, then we are going to process ptr. For what? We are going to process for printing the value of the information part, data part, for counting the node, we will process. So this is a process. ptr tends to data. Okay. We will process this first node, then ptr will be incremented. Then it will be incremented using this statement. Okay, na? Or we can write here ptr or ptr is equal to link ptr. We can write this also. As I have told you, there are two linear arrays. One is info and another is link. Then we can increment the value of ptr by this. Okay, and we will check process to. We can also check process to info ptr. We can write also this. In place of this, we can also write this. Okay, it will depend what assumptions we have taken. Okay, so traversing means we are going to travel. So how this will be implemented in C language? Simply ptr is not equal to null, then we will print the value of that data part. ptr is equal to ptr next. Keeps going on. Next. Okay. Now, if we are going to search a value, it's also very easy. We will move this ptr. Now we will check is the information part contains 4? No. Then ptr is equal to ptr plus 1 or ptr is equal to link ptr. Then it will point to this. Now we will check is this information part is equal to 4? No. Again increment. Information part is equal to 4. No, again increment. Information part is equal to 4. Yes. Then it will, the value of this, we will give the value of this to some variable location and we will print this location. We will find element at this location. Okay. So this is simple searching the element in a linked list. है ना? अच्छा, there is one more thing. We can search the element in unsorted list as well as in sorted list. Okay. There is no issue in unsorted. We will just keep on checking. Okay. In case of sorted list, what we will do? So when we discuss about sorted, na, there is one disadvantage of linked list that comes. So there is one disadvantage of linked list is that there is no binary search implemented here. No binary search is there, because while in case of binary search we use the indexing, but in case of linked list, elements are scattered here all over the memory, है ना, that are linked with the help of a address, with the reference. So that is not possible. So this is the only one disadvantage, that there is no binary search implementation in case of linked list. Okay. Now the question is that how we are going to search the element in sorted. Then we will use that relational operator, less than or greater than. Until unless the element is found, we will keep on tracking until the ptr is not equal to null. This is the only way. Okay. So this is how simply search value. If we get the value in the data part, or we can write it info ptr. If that item we are going to find is equal to the info ptr, then it's okay. Otherwise, we will move to next node, we will move to next node, and so on. ptr is equal to ptr next, like this. Okay. Now inserting. Now students, for inserting a node at the beginning, right? So first of all, we need to know the concept how we are going to insert the element. है ना? Let me explain you first. So for example, this is my node start. Okay. This is my given linked list. For example. Okay. Now I have to insert the element. Either I will insert the element at beginning, either at last, or in between. Right. So what I will do, it will be easier if I found the location where I want to insert. Okay. But what is the insert mechanism works? So for insertion, I will consider a list, free storage list. For example, there is one free storage list. I will consider my memory in the form of linked list, that is a free storage list. This is called free storage list, or we call it avail list also, available list, avail list. Okay. So the avail, the pointer named avail is pointing to the starting address of this free storage list. Okay. So we will check, the first condition is that we will check whether the memory is available or not. This is the first condition. We will check always. In every insertion algorithm, we will check whether the list is available or memory is available in a free storage list or not. So we will check if avail is equal to null. If avail is equal to null, it means memory is not available. Then we will print overflow. Then overflow is printed. It means that no memory is there. We will print overflow. Okay. If there is available space, avail is equal to null, print overflow and exit. If no, then what will happen? We will take a node from here, right? Then how we will going to take it? This avail will give its address to some new node, some new address new. Okay. Now this is my node n, which the address of this node is with new. Okay. This avail will give responsibility to new, and new will take this new node to this list. Okay. Now it's my choice where I want to insert it, at the beginning, in between, or last. This is the concept. So every insertion algorithm will have these 3 points common. Number one, we will check for overflow condition. If not, then what will happen? Avail will give its value to new, and avail will start pointing to the next. in the free storage list, because we have to arrange this free storage list also. Na? Then avail, value of avail is updated like this. Avail is equal to link of avail. Number 2. Number 3, then the information part of this new will have some item. We will insert some item. We will insert some item. Okay? And the link part of this new will have none. Okay? Some item I and none. So these 3 steps are common for all the insertion algorithms. Okay. After doing these 3 steps, the 4th step will be, if we want to insert in beginning, then what we have to, what is the procedure now? Now, if we want to insert this node in start, then what will happen? What will happen? The address of this start, the next field of this new will have this start, and this new will come into start. This is the beginning, right? Number 1. Now, if you want to insert as a last node, then what will happen? This new, this link part will have that new here, and already we have null. So 2 algorithms. Now, 3rd is, if we want to insert in between, then what will happen? We will have this node A and we will have node B. We want to insert this node N in between, then what will we do? We will do the next of this A will have the address of this new, and the next link part of this new will have address of this B. So this is how insertion works. Okay. Okay, students. So let us see the algorithm. Now you can see these are the steps that I have told you. Step number 1, step number 2, step number 2, and step number 3. Right? These are the common. Now, if you want to insert a node in beginning, then what I will do? New next, new node next. This start will come into new node next field. Okay, and the value of new will come into start. Right? This I have told you already. At the end, see step number 1, step number 2, step number 3. These are common. Okay. Now for inserting at the end, what we will do? This null will come. This already we have. Step comes to node number 3. Then set PTR is equal to start. This is the step. Set PTR next into PTR. PTR is the current location. So for example, we are starting. This is the PTR. So we will insert this element at the last. The address of new node will come into PTR next. Okay. Now, node that has value num, we have this is step number 1. This is step number 2. This is step number 3. Right? These are the common steps. Okay. Now we have initialized one more variable. Save. Save is the variable which will keep the address of preceding node. PTR is pointed to the current node, and the node which is preceding, which is before that current node, the address of that is save. So we have initialized here one more variable, save. Okay. So we will check here the data of save is not equal to num. Then PTR value will come here. For example, this is start. This is start. Right? This is my given linked list. Okay. So what happened? This is my start. Okay. Now what I have done? PTR is here. Is the information part is this? No. Then this value of PTR will go into save and PTR will move next. Is this the part which I am looking for? After which I have to insert the node? No. Then PTR value will go into save and PTR will come next. Right. Now I will check whether this is the element which I am finding. Yes. If this is the case, then inserting a node after node value number. Yes, this is the case, then I have to insert. So now this PTR this is the save and this is the PTR. If the information part is this, then I have to insert a new node here like this. So the algorithm works like this. Okay, right? Similarly, we will do the deletion here. For deletion, we will do just reverse. While doing insertion, we are demanding, we are checking whether the free storage list is available or not. In case of deletion, what we will do? After deleting the element, we will return that node back to the avail list. Right? So, in case of insertion, we will check overflow, while in case of deletion, we will check underflow. What is the underflow condition? Underflow condition is that we will check start is equal to null or not. If it is null, then print underflow and exit. Okay, just you have to keep in mind this. Okay, just make the diagram and write the algorithm. Okay, so let me show you the practical implementation. So, for example, I have told you that how we are going to define the node using this structure, struct int data, and second is the self-referential pointer, struct node star link. Right, students. Now, in this our main function, int main function, I have declare a variable of this node type, for example, struct p, and I have put initially there is no node in our linked list, so I have put p is equal to null. Okay, then I have made a function called as append, and I have passed this p and some value 11. First time, again I have called this append function 12, for example. Okay, then I have display. So using traversing, I have display the value of this p. Okay, return 0. So this is my main module. Okay, now my aim is to implement this function append. So this append function will implement my insertion algorithm. Okay, so see, so I am writing here append function void append. First parameter, so this is my address. This is my address, na? So this will keep the pointer variable, will keep the address, na? So I have initialized struct node star q and int num. Okay, so this is the pointer to a pointer variable because I am going to keep the address, is address of p. So the address of pointer variable will be kept by a pointer variable. So I have taken here double pointer to a pointer variable. Okay, this star q will be kept here, right? So I have taken a temporary node, struct node star temp. Okay, so I will check if star q is equal to null. It means that initially my linked list is empty. There is no node in my linked list. So this condition will be true. Then what we'll do? Then perform this operation. Temp is equal to struct node star malloc function that I have shown you, malloc size of struct node. So what does this mean? This means that memory is allocated dynamically according to the size of my node. Okay? And what is this? This is the typecasting. Because this malloc function will return the void star type of value. Its return type is void star. Okay? So void means empty, but I have to return the value of this node type. So I have typecasted struct node star. Okay? So the data part of temp, the value that will n, that will come, and the link part will have null. Right? Now this is how we have created the node. After creating this node, now this temp, the value of temp will come into star q. So this is the code by which a node is created in computer's memory. Okay, students? So the node will be created such that here with the help of this temp. So initially I have called this p11, I have put here 11 and null will be there. And then afterwards this q will have its address. Okay, this is how the node 1 is created. Okay. Now, secondly, Now second time I have called append function. So when I have called append function second time, already I have one node. So there is no null. Then what happened? Then I will write else part will be executed here. Else, what I have done? This queue will come to temp and it will check if temp's link part is not equal to null. If not equal to null, then I have to move forward because I have to add, append means I have to add a node at the end. Then temp is equal to, temp will be awaited, temp is equal to temp link. We will increment the one value of temp. Okay? If this is not the first node. For example, I have more than 2 nodes like this. This is my first node, this is my second node, this is my third node. For example, so I have this is a queue node. So firstly, temp will point to this. So is that link part of this temp will have null? No. Then we will increment the value of temp. Now the temp link part of temp will have null? No. Then we will again increment the value of this temp. Now temp is pointing to this. So it will have null? Yes, it is null. Then create a node. So for that, what I have done, node will be created. For creating a node, I have taken another variable star r with the help. Then what we will do, if the condition is true, if this is false, temp, there comes the null in a node, then what we will do? New node will be created similarly as we have created before with the help of this struct node r star malloc size of struct node like this. Okay, r's data part will have n value num, ठीक है ना, r link part will have null, right? Okay, now at last this will come in my this will point to this queues link. So the value of this temp link part, the temp's link part, the value of r come into temp's link part, है ना? Value of r here r, and we will close the loop. Okay, right students. So whenever initially there is no node, this loop will be executed, right? If there exist some nodes, then every time we will append function is called. Append function, what this append function is doing? It is adding a node after a given node at the end. For that, this code will run, right students? So append, then display simple traversing. We have already discussed traversing and return. Similarly, we can call the delete function for deleting. Deleting means we have after deleting we have to free the space. That is the concept of garbage collection. Matlab free means the memory which is deleted that can be reused. Okay. So this is the display function. Okay. So students, I hope you will understand how we are going to implement a linked list. Okay. Similarly, we can call display. Similarly, we can call a delete function. Delete a node with given information. For example, I want to delete this. Okay. Then again call display. Okay. Like this, we can call the function. Okay, students. I hope you will be able to know the implementation of a linked list and how programmatically we can implement it. Okay. So thanks for today.